How about the clock stuff? Good? Anybody need to see anything with any of the?
Do you always want us to put 0 if it lands on, like, whatever base it is? Does that make sense?
If when you add, and then divide by the clock number, if there's no remainder, it's always 0.
Okay.
Okay, that's because, and this is a little bit different because this clock has a 12 on it, but in real clock arithmetic, it would only have a 0 up there at the top, right? This is one way they're like bases. In base 5, there is no such thing as a digit 5, right? It's 0 through 4. In base 8, there's no such thing as a digit 8. It's 0 through 7. Well, the same thing in clocks. In clock 12, there's no such thing as a 12. It's 0 through 11. There's 12 numbers, but it's 0 through 11. So everybody's good. Then nobody needs to see any of the methods. I could say do the subtraction and use the adding the inverse method, and you could do okay.
Wait, I have a question.
Jessica? From the assignment?
Yeah. That was over the change, or one of the subtraction ones, or it was the adding the inverse.
Okay.
When I got to the homework, I couldn't remember.
What was the problem?
So it was 2 minus the power 3.
2 minus 3 in clock 5? Who could come do that using, you want the inverse method? Who's comfortable? If nobody else raised their hand, everybody in this class, I should be able to call on you, and you should be able to come up here, right?
Can I ask, like, what you're trying to, like, get with the answer, I guess? I don't know how to explain my question. So when we work the problem out, what are we trying to get?
We're trying to get the answer to this subtract problem in clock arithmetic.
But how do you do
That's what we're, Sarah, can you? You're not comfortable with it?
No, not the inverse.
Not the inverse method. Kelly, do you want to come up and be sure and ask questions if you're not comfortable.
So, because of that families, we know that we could write this as 2 plus 3 inverse 1. And then since we're looking for 5, we're seeing what 3 plus what equals 5. So 2 would be its inverse. So it would be equal to 2 plus 2. And then that would be
Stick a little 5 by your plus sign in your second, yeah. And do the same, well, yeah, do the same thing down below. Okay, step aside. Who wants to ask her a question? Yeah.
Could you like explain your process more? Since like why did you put the -1 above the 3?
There's no negative numbers in clocks, and so that's how you write the inverse. So it's the opposite of 3 in the clock, I guess. I don't know how.
That's a good answer. I'm not sure if it's good enough for her, but let me try it this way. Yeah, you can sit down, thanks. If I take -9 subtract -3, this is not clock, this is just regular integers. We learned the other day that subtraction is the very same as what? Adding the inverse. So what I'm going to do is I'm going to put the inverse of negative 3. Subtracting a negative 3 is the same as adding the additive inverse of negative 3. But what is the additive inverse of negative 3? Well, an inverse is something that when I'm adding produces the identity, which for addition is 0. So what is the answer here? 3. 3 is the inverse of negative 3. Okay? So now, up here where I've got the inverse of negative 3, I'm going to rewrite that and say the inverse of negative 3 is 3. Oops, I've left my negative off. So now I do this addition problem instead of this subtraction problem. Instead of subtracting a number, I'm adding its additive inverse. Does that make sense?
Yeah, it makes sense now. 'Cause
This little problem here helps me find what the additive inverse is.
I guess in elementary school, whenever I learned this, I remember doing the minus cancel each other out so they become positive.
Mhm.
So it makes sense.
Right. So you end up with this.
Yeah.
But that's a trick. Making the 2 marks, that's a trick. The reason why it works is because subtraction is the same as adding the inverse, the additive inverse of a number. To find what the additive inverse is, you take the number and you add its additive inverse to get the identity. So that helps us to find what that is. So the same thing happens here. Addition is the same as, subtraction is the same as adding the inverse of the number. But in clocks, I don't know what the inverse of the number is. So I come down here and say, and actually we need a 0 here because there's no such thing as a 5 in clock 5. Because if it's 5 and I divide by 5, what's my remainder? 0. So I say 3 plus what gives me 0? Well, 3 plus 2 is 5, divided by 5 gives me a remainder of 0. So 2 is my inverse. So up here where I had the inverse of 3, I replace it with what the inverse of 3 is, 2, and then I do the problem normal. Does that make sense? Should we do another one?
Yeah.
Should we make one up, or do you want to pull one from the homework?
I have another one. It's 11 minus 15 and 16.
11 minus 15 in clock 16. Who would like to come do this one with the inverse method?
Can I try it?
Yep. Hey, there's somebody that's not, they're a little shaky and they're willing to come up in front. That's great.
Is that right?
Nope.
No.
Subtraction is the same as adding the inverse. Now it's right.
Okay. So then I would do so it would be 11 plus wait, so can you explain it to me? It's just say like, can you walk me through that?
So what we'd like to find out now is what is the inverse of 15 in clock 16?
So what do you mean by like finding the inverse of it?
Yeah, do you know what the inverse of 15 is in clock 16?
No.
Okay, that's what we need to find.
Okay.
So how do we do that?
I really don't know.
Okay, the inverse is the number that gives us the identity.
So it's what brings it to 16 or 0.
Yes.
Okay, so what can I add?
What
to
brings
15?
what? 15.
So then it would be 1.
Yes, so write that down. 15,
Wait,
start over, erase that piece. We want 15 plus what?
15 plus 1.
Okay. You figured it out, but put a blank.
Oh, okay.
Okay, equals 0.
So
And in clock 16, so put your little note, oh, put
Where
it by
do I
the
put it?
operation. You always put it by the operation with
This
clocks.
one?
Yep.
Okay.
Okay, and you've already decided it's what?
It's 1.
It's 1 because 1 plus 15 makes 16. And when I divide 16 by 16, it goes in one time with a remainder of 0. So 1 is the inverse of 15. So go up and put equals on the end of that last expression. Nope, up above. Right there, equals. And rewrite that, but in place of inverse of 15, put what the inverse of 15 is.
So 1.
Yeah.
Okay.
Now do that problem. What's the answer? 11 plus 1 is 12. Divide 12 by 16, it goes in how many times? 0 times, with how many left over? We're not taking 12 into
Oh.
16, we're taking 16 into 12.
So 16 and 12 would go to 0 times.
0 times, but the remainder is 12. So your answer is 12. Have you all figured out when you're adding two numbers that, whose sum is less than the base, you really don't need to divide, you just write the number? Okay? Now, how would we check if that's correct or not? And do what?
And start at 15 and go.
Do a 16 clock. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Let's see. 1. That's right. So 1. I'll do it inside. 1, 2, 3, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. That's a 16 clock, right? And start where? Start at 11 and do what? Go backwards 15. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Our answer is, it better be the same thing we got by using the inverse method. What's the other way to check it? Convert this into a fact family with a missing add-in. What would it be? 15 plus what gives me 11? I'm at 15. What do I going to need to do to get clear to 11? Well, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I'm going to have to go 12. So here's my answer here, here, and there, doing it all three ways. Okay? Yeah. Have that look on your face.
So if the base, or if the answer, when we're doing the inverse, if it's big, will it ever be bigger than the clock base? Like, will we
No,
have to divide?
there's no such thing as a number that's bigger than the clock. In that clock.
So will we have to do the division with the inverse ever?
I'm not quite sure what you're asking.
Like, you know how you had to do like 11 plus 1 equals 12, and then you divided it by 16, and the remainder is 12?
Oh,
Will we ever have to do that when it's a different number than what we got originally? Like, will we have to divide? Because like all the ones that we did, we didn't have to, but I didn't know if we didn't have
if you do it that way, you could possibly, let me give you one here.
Okay.
Let's just do a clock 12. 7 minus 5 in clock 12. By doing the inverse, we're going to say that's the same as 7 plus what? Inverse of 5, right? I don't know what the inverse of 5 is, but I know if I take 5 plus something, it'll give me 0. That will be the inverse, and this is in clock 12. So what will that be? 7. Okay? So if 7 is the inverse of 5, I'm going to come down here and replace 5 with that. 7 plus 7. Now I'm going to have to divide.
Okay.
What's my answer? 2.
Okay.
Now, the reason I didn't give you very many of those, or any of those, is because I could have just done 7 minus 5 is 2.
Okay.
Does that make sense?
Yeah.
And if you can subtract, do it. But if you've got a smaller number subtracting a bigger number, you can't go into the negatives. You've got to work one of these other methods. Are we feeling more comfortable? Sarah, could you do one? She could do one. Let's just have everybody work one at their seat here, just to, and let's start with the inverse method and then pick one of the other two to check it when you're done.